Since our ancestors first learned to walk, we've been making predictions, and we've gotten really good at it. But there are some things we just can't predict, and we'll never be able to, all because of chaos. So what is chaos?
Chaos theory was coined by Edward Lorenz in 1961. He described it as any time the exact present determines the exact future, or the approximate present does not determine the approximate future. Now that sounds really complicated, but it really isn't. First, we need to understand that to make any prediction at all, knowing the starting values of a system is necessary, whether it be the mass of a planet in a solar system to predict orbits, or what temperature it is outside to predict the weather. Once all the initial conditions are found, models and equations can be used to predict the future of a given system. But it's important to note that it's impossible to predict the initial conditions with perfect accuracy. This is where the difference between stable and chaotic systems start. In a stable system, small differences in the initial condition don't compound over time. The model's prediction will stay roughly as accurate as the initial measurements were. Alternatively, a chaotic system, any difference at all in the measured condition from the actual condition will compound exponentially over time, making long-term prediction of a chaotic system impossible.
Now, chaos can be difficult to conceptualize, so here's a simple demonstration of it using something we should all be familiar with, a pendulum. Now, a pendulum by itself is a stable system, so if I hold it at roughly the same position, it will do the same thing consistently across multiple trials, no matter how many seconds after it was let go. To demonstrate this, here are 4 clips of the pendulum started from the same position. And look, the pendulums stay almost exactly aligned with each other. This is a perfect demonstration of how you don't need perfect initial conditions to approximate a stable system. Now let's see what happens in a chaotic system. A double pendulum, which is just 2 pendulums attached to each other, is a chaotic system. So despite the initial conditions being similar, the pendulums will diverge drastically over time. Wow, that was interesting. The pendulums diverged quickly. At 1.5 seconds, they were all in completely different locations before slowing down due to friction. So what does chaos theory have to do with our everyday lives? Well, chaos is what makes it impossible for us to tell the weather more than a week in advance, and for us to predict what our solar system will look like in more than a few million years.
Will the Earth even exist then? It's impossible for us to tell. All thanks to chaos theory.